and use these words like distance, speed, acceleration in your daily life. But in grade 9 subsequent chapters, we're going to learn them scientifically. For those of you who wish to pursue a career in science, this is the beginning of a very, very important stage. These are very interesting topics. And we'll start learning them with the concept of motion. Let's look at motion with the help of this example. So there is a race event in this stadium and you are sitting right over here. Just imagine this to be a real race event. All these runners in front of you, they are running towards the finish line. The person who's about to come first, let's call him runner number 1 because he's about to come first. The guy just behind him is runner number 2. And these two guys who are mostly likely going to lose the race, but they're running at the same speed, runner number 3 and runner number 4. Let's assume that they're running at the same speed. I know that doesn't happen in a real race event. At a real race event, there is always a small difference, even if it is for 0.0001 second, even if it is for the last 2 spots. You see, because no one wants to come last, no one wants a banana. Okay, now I want to ask you this question. You can obviously see that all the runners, they are moving. They are running, so they are moving, they are in motion. But the question is, are you moving? Are you in motion? Some of you might think no. So, let's zoom out. You are sitting in the stadium. The stadium is in a city. The city is on planet Earth, which is spinning and revolving. So, if everything around us is just moving all the time, how do we really start talking about motion? How do we try and understand motion? We need to have a simpler way of looking at it. We need to have a common viewing point, or we can call it a reference point. Remember the words, reference point. A reference point is also referred to as origin. Now let's look at some examples. Let's say if the reference point was at the sun, which means somebody is actually observing from the sun. So the earth is obviously in motion, but you and all the 4 runners which are on earth are obviously also in motion. If the reference point is you who are sitting in the stadium and watching the race event, for you obviously the runners are in motion, but hey, the sun is also in motion through day and night. Isn't that interesting? But right now we just want to study the motion on earth, so let's forget the sun. Let's just choose another reference point. How about your friend who is just sitting next to you? Now you and your friend, you're just sitting and watching the match, you're not running, so we can call you a stationary body. All the 4 runners who are running around, we can call them as moving body. What we want to do now is, we want to take a stationary body as a reference point and a moving body as a reference point and try and see the motion around. So let's pick your friend who's a stationary body. This is very easy. To your friend, you are obviously at rest and all the 4 runners are moving. Let's look at this on a table. With respect to your friend, you are at rest and all the 4 runners are in motion. Okay, now before changing our reference point to the moving body, I want you to look at these 3 pictures. Picture number 1, this is at the beginning of the race. You can see that all 4 runners are at the start line. This is picture number 2. This is roughly at the half time. You can see 1 and 2 are marching ahead and 3 and 4 are much behind, but they are still together because they're running at the same speed. Picture number 3, this is almost at the end of the game. 1 is about to win the race, 2 is slightly behind, but 3 and 4, they are still running at the same speed. Now let's move our reference point to our moving body. Let's pick runner number 3. Let's see how all the other people are behaving with respect to runner number 3. The first 2 runners, runner number 1 and 2, they were with runner number 3 at the start of the race, but now they are clearly far ahead, so they are in motion. What about runner number 4? You can see in all the 3 pictures, every time runner 3 looks to his right, runner 4 is always there. So runner 4 is always at rest. What about you and your friend? Let's look at the last 2 pictures again. In picture number 2, you and your friend are sitting a little ahead of runner number 3. In picture number